Hey folks, it's Rob Flux here with another Sunday session, and today we're talking all about sound and vibration, and not just the good vibrations that come to you from the Beach Boys, but all the vibrations that come from all the noises that are out there. And today, in order to go through this, we've got a very special guest. So we've got Monica Saralut-Safon from VMS Australia. Hey Monica, how are you?
Hello, hi Rob. How are you? Hi everyone.
I'm fantastic. So all about noise and the vibrations that come from noise. Monica, that's what we're going to talk about today. So firstly,
Right.
give me a little bit of insight into who is Monica and who is VMS Australia, and why are you the experts we should be listening to today?
All right. So my name is Monica. Been in acoustics now for 13, 14 years. I've been with VMS as a operations manager, leading the Queensland branch. My experience in acoustics go from Sydney. Basically, I started my career in Sydney for maybe I think 10 years. And I moved across to Queensland for the last 2 and a bit years to basically start an office here. And I've been working with the Queensland regulations and New South Wales regulations and Victoria for quite some time. We also do some work overseas and anywhere around Australia. So my background is in acoustics. I studied acoustic audio and acoustics. Forgotten my career there. So audio acoustic design, design science in audio acoustics from Sydney Universities. I think a lot of our colleagues graduated from that course. It's a very good course. So if you're interested, have a look at it.
Very good. So who is VMS, and what does
Oh yeah.
VMS stand for?
So yeah, VMS is it's a little boutique firm. We are all pretty much friends, very long time friends. We all started in Korea similar times. And now they've migrated to start their own business. VMS stands for Vibration Mechanics and Sounds. So that encapsulates a lot of the things that acoustic consulting would be engaged in. So we're a small boutique firm with just lots of friends that likes acoustics and just talk geeky out in acoustics all day long. We solely do acoustics and nothing else. So if you and we're based in Sydney, Brisbane, and in Melbourne.
Very good. Okay, well let's start with, what is a definition of sound?
So the definition of sound is basically a vibration, mechanical wave that excited the air particle. So that is the air element or the air particles that enters into your ears, and that's what you hear, and that becomes sound. And then if it's vibrating some other medium, say if you're sitting on the floor and the ground is moving, it's actually a vibration, but it's it's the mechanical movement of a particle, basically. So that's what actual physics of it is.
That's the physics of it. And way back in my electronics days, I used to help build speakers and repair sound systems, that sort of thing. We used to vibrate a hell of a lot of sound. Which brings us to I guess there's lots of different types of sound. There's clearly pleasant sound that we're all wanting to listen to, and then there's noise. Is there an actual definition for the difference between them? Because I know that when I listen to a piece of music, my style of music and someone else's style of music might not be the same. What I think is pleasant, they might think is noise. So how does that work?
Definitely. So generally, physics of sound are the same, like Robbie explained before. But in terms of perception of the actual sound itself, then there's a distinction between it being sound and it being a noise. So noise is something that basically you're unwanted, and it's a pollution. So say if Rob is listening to the Beastie Boys, and that's not the kind of vibe I like, that is considered noise to me. And to him it's a pleasant sound and he vibes away with it. So that's the definition between noise and sound.
Okay, so and then that's very, very subjective. So
Definitely.
so at some point there's going to have to be, I guess, a technical definition of that starts to come in. And so I guess the level of that noise, whether it's pleasant or otherwise, once it gets to a certain volume level, or it's called an attenuation from memory, once it gets to that certain attenuation level, then it's considered to be noise to everyone. Is that right?
Yeah, so obviously there's a level of hearing that you need to respect. Your ears can only receive so much loudness of noise. So say if you start basic, I guess basic gauge is if your ears start hurting, it's generally not a safe environment to be in, and that's when it becomes absolute noise for everybody generally. Having said that, if you're under an influence and you're dancing right next to a speaker, you might not feel it as much, and just because your I guess your function in your ears are sort of skew a little bit with different things, but that doesn't mean it's not going to do damage to your body. It's just that you don't feel it. You'll definitely hear your hearing shift the next day, and that could prolong exposure to that can actually lead to hearing damage.
Yeah. So just the way you said, if you were under the influence and standing next to the speaker, was almost like you were blaming me and saying that's you, Rob. I remember you. Like I may have stood next to a couple
Dancing away.
of dancing away. Let's not go there. Let's not reenact that. Okay. So what are some potential sources of noise? So there's clearly, like, we're looking at this from I guess, a property development perspective. So that we clearly have a development site, but there's impacts from noise coming onto our site, and then the impacts from our site and the noises that we're going to generate is kind of how I'm interpreting it.
Correct.
Let's have a look at the impacts from noises external to our site. What are the things that we need to be aware of?
All right. So if you found a site and it's on next to a major road, if it's an arterial road, if it's a collector road, generally you can already assume that that has an impact onto your site, whether or not, depending on which state you're at. If you're in Queensland, usually you'll get you get a noise overlay to tell you that you're in the zone that you need assessment anyway. In New South Wales and in Victoria, generally, you know the busy roads, and the council will tell you once you have a chat with them, and they will tell you that this is actually busy roads. You need to consider for acoustics. But in terms of noise impact onto your site, you have your roads, you have your rail, and you have the aircraft. So flyover, if you're within the ANEF, which is the aircraft exposure contours, forecast contours, and then the industrial or commercial next door to you. So you've got either petrol station, you've got childcare center, you've got shopping center, or multi-story car park, those kind of things, noise impact onto your site.
Yeah, I love the fact that you say childcare centres and noise, that those they make a racket. There's also things like quarries and things like that.
Oh yes,
Not so
definitely.
often, but anywhere that maybe a pub or a club where there's going to be potentially late night music and things like
Yep.
that. That's also going to come into play,
Yep.
or wherever there's going to be, I guess, a herding of people together. I guess they themselves can make a heck of a lot of noise. So
Yeah.
yeah. So any others that we've missed out of that, or?
Yeah, so there's like warehouses and storage space and those kind of things that you can see there's vehicle going in and out, deliveries, and restaurants sometimes as well. Like if they've got deliveries next door, you might need to. Usually, if you're next to a commercial, you can already start to need to start thinking about whether or not you need what kind of mitigation or control you're going to need for your site, or talk to your consultants about it.
Yep, very good. And then there's the potential noise that our site could be generating.
Yep.
So what are some of the noises that our site could actually be generating depending upon what we're building?
Yes. So typically, if you're doing standard residential, not a lot of stuff, not a lot of noise you'll be generating. So if you're doing like a duplex, so you're only adding one more carport, council's not gonna worry about that. And if you're putting in one more aircon, council's generally not going to worry about that. It's more of the subdivisions or the multi-res that may trigger an acoustic assessment for the noise emission outside of there. So there's traffic generated by your site. There's additional car park on your site. There's air conditioning. There might be, other fans or mechanicals services, so car park exhaust or kitchen exhaust, and those kind of things. And so I think those are the things
So
for residential. Did I
So if
miss
we're doing
a question?
larger projects, so if we're
Yeah,
doing a multi-level apartment complex, or we're doing, a 10 to 20 plus townhouse type project, that when we get to that sort of size, the impact on our neighbours then has the potential to,
increase.
to increase. So,
Yep.
it's not just them harassing us. That's the key point, folks. Also, in some of those developments that we might be doing, especially those larger ones, there's going to be potential opportunities for us to have, I guess, people noise. We just touched on people noise as something that
Yes,
might
that's
impact
right.
us.
Yep.
We've got communal open space or rooftop gardens and things like that where people are actually going to all get together. There's potential for that to impact others as well.
That's right.
Yeah. What about if we're doing, so most of us in, I guess, watching this show would be doing residential, but if we're building anything in and around the commercial space, are there things that we need to be worried about there?
Definitely. So commercial space are a bit more complex, and obviously there's a lot more moving parts and noise generating parts. So, for example, I'll pick a childcare again. So we've got childcare center, you got kids generally. So kids gonna have an outdoor play area. That's always gonna be tricky to assess and manage because you little kids, you can't really manage them. So you have to create a space that is that's able to control that kind of noise. There's peak hour traffic drop off and pick up. So those kiss and ride kind of parking arrangement, or sometimes if you don't have that and you're using public roads, sometimes the council would ask you to how would you address this, and usually that comes into your management plan, but not actual noise control kind of thing. And say if you're doing a shopping center, then you definitely have deliveries, you've got mechanical services for sure, and you've got parking, and you have people noise. And if you're doing petrol station, then you've got tankers, you've got all the uh, commercial commercial premises that will lease out your property, and all the people and the parking and similar kind of thing. So those elements, your consultants should be able to tell you. Unless there's specific things that the council asks, then you might need to bring that up front with the council and say, this is what I'm going to try and do. Can you tell me exactly what you want from me, kind of thing?
Yeah.
Yeah.
Very good. So we've identified the different kinds of sources, and including us being a source. But when we actually go to do our site, obviously the potential impact of this with regards to remedies that we need to do might be significant. How do we actually identify whether our site is actually going to need an assessment and need, I guess, some form of measure against it? So I know that we're looking at multiple jurisdictions here. So is that
Yep.
going to change how that's assessed in different states?
Yeah, that does change a little bit. In Queensland, it's pretty black and white. If you're in the contours, you have to assess it. If you're outside the contours, you don't have to assess it. Another thing
I think you
is
meant overlays, not
sorry, the
contours.
overlays. Yes, the overlays. Sorry, the noise overlay. um, so the noise overlays. Obviously, there's the trains and there's the roads and there's light rails and different things that they have on there. Just make sure you click all of them so that you can see what overlay is on your site. And there's another one is that if you're within the 25-meter footprints of the state's asset, so the roads, the rail, or the potential future one that they may plan, you may need to also look into protecting your site for that. For New South Wales and Victoria, generally, if it's busy road, you can already assume that it is going to be required. Typically, the immediate houses are required. The one further setback, you might need to clarify that with the council if they want you to. But it is not as clear as Queensland, where we have the noise overlays. So you might need to have some local knowledge of whether or not that road is busy. So there's several sources that you can find of how busy that road is, and your town planner usually can tell.
Yeah. So there's a thing called a road hierarchy, which is a pretty good clue for that. So
That's right. Yep.
if it's a highway, that's pretty clear.
Yep.
If it's an arterial or a collector road, then chances are that you're going to have a lot of traffic on that.
Yep.
But if it's a normal suburban road, then chances are you're going to be
Should be
okay.
alright.
So
Yep.
understand your road hierarchy, folks. Usually in your local planning portals, you'll be able to turn on that hierarchy and be able to see what that is. Either way, your town planner will be able to help you to understand that. What about things like understanding, I guess, things like flight paths and that sort of stuff? You used a technical term that I kind of missed before, but there's an actual name for how they measure the flight paths. What's that called?
Yep. So if you look up the ANEF, it's called the Australian Noise Exposure Forecast. So basically, once the airport figure out how much traffic they want onto their airport at for the next 10 odd years, they will release this contour lines called ANEF, and it's got similar to the noise overlay of the traffic. So it has different contours of how much noise you're getting exposed to in terms of, so this, how many aircrafts basically are going to come in and out within that buffer zone that they've got. And obviously, the closer you are to the airport, you're going to get exposed more, but not necessarily in real life, because obviously that's in the air you're talking about. And sometimes it's, if you're real close, like say the Gold Coast Airport, if you're really close, you can actually hear the takeoff in a certain angle, so that you're not really impacted by the airport that much, as the what the ANEF may lead you to believe it's within like the very, very closed zone, but it's actually not that bad.
Okay.
Yep.
Look, we've identified at this point that, hey, we've got a potential source of problem. We're not really sure if it's a true problem or not a problem. Who do we have to talk to in order to understand how big the problem is? And then what does that person do in order to determine whether or not the problem is there and how big the order of magnitude of that?
Okay, so once you've determined that your site is within, a certain trigger, or you think that you may going to need an acoustic input, a design input, then you usually you can now know another acoustic consultant. There's VMS. You can go to another consultancy, or you can ask your friendly town planner to recommend you an acoustic engineer. Usually they'll be able to, they'll have a couple of people that they've worked with and that they like working with. My recommendations would be, if you know the town planner that you work with very well, use the town planner's recommended engineer, because the one that they work with regularly would work well with them. But ask this question though, whether or not they've worked together before and they work well together, because if the site is tricky, you're going to need that relationship, and you're going to need that communication line to be really, really streamlined, and that's critical for your development basically. So that's the level of complexity of the site. Once the acoustic consultant is sort of engaged, or not engaged, even prior to engagement, you can basically give them a ring and say, what, just, can you give me a rough idea of how crazy this site might be? Usually they can tell if you're right next to like a highway and you're abutting against the highway's border. They could probably, there's going to be noise wall involved. There's going to be a whole bunch of back and forth with the council, with the actual authority, so like RMS or the TMR, in that sense, to negotiate or to clarify what exactly we can do here, and what we can come to a conclusion, or what we come to a resolution with them. They're going to have their own preference. We're going to need to have our own preference as well, and then have to come to the middle ground.
But how do we actually measure the noise itself, and how do we
Mm.
determine that there's a problem? So now, my lay understanding, we put a thing called a decibel meter in place. We hold that there for a period of time. It records how much noise is actually coming by. So firstly, what is a decibel meter? What's it measuring? How long do we need to stick it there for? How does that all work?
Yep. So that so the acoustic consultant, once you get them on board, they'll have to come out to do a site survey, and so it's specific to your site. And what that allows them to do is to capture exact how much noise is actually being exposed to your site, and also getting understanding of what the surrounding properties are doing. So say if you haven't been to the site and they haven't been to the site either, they don't know the area very well, walked around and have a look. Oh, wait, there's a petrol station being developed here, and then those kind of things, those kind of information will be able to get captured at the earlier stage, and the consultants then put the logger. So there's two types of measurement instruments that are typically used in consulting land. So there's a handheld one. So handheld one gives you a noise level straight away, and then you're looking at the source and you're assessing the environment, and it tells you how loud different sources are, and while you're doing the measurement, so that you can report that back and determine, assess what kind of risk these kind of sources are imposing onto your site. Another type of measurement is noise logging. So that one, you'll hear that term a lot. Yeah, so noise logging is basically we put the similar type of computer instrument into a box with a microphone that sticks out of it, and it's in an environmental protected case. So rains, if it rains, it's okay. You can then they will then put this on your site, facing the most exposed barrier of facade of your site, or boundary rather, and then determine how much noise you're getting onto your site. Now that exercise usually lasts between a week to 10 days, depending on the weather. It also can only be done if it's a road traffic noise. It can only be done during school terms. So public holidays have irregular traffics, and so that has to be discounted from your measurements. But we need to have at least a valid 7 days of non-affected data generally. So that's how
Yep.
we measure it.
So avoid school holidays.
Yep.
So always do it during school terms, and you got to make sure, depending upon the source. I think you said between 3 days and a week. Is that correct?
Yeah, so the 3 day one, if you're just exposed to the railway line or aircraft noise kind of thing, so those kind of things doesn't really get affected as much with the school holidays. So you can generally measure any time as well, and up to minimum 3 days, I'd say. But my preference would be to do at least 5 days of data, just in case if anything happens, they have room to play with. So just factor that into your time frame. Yep.
You can choose the best 3 days of answers.
Of
Yeah.
the five, rather than the only 3 days you've got, kind of thing.
Yeah. uh, so I guess then there's like how I guess the actual level that it's actually measured in. It's measured in a thing called decibels.
Yep.
So a lot of people have heard the term decibels, but they don't really know what that means. Like, give us a little bit of understanding of what a decibel is, and I guess how many decibels is good and how many is bad.
Right. The decibel is a level of quantification to determine, so standardized, rather than if I was to use myself as a standard measurement, I'll listen to something and I said it's loud or it's not too loud. So those are subjective measurements, a qualitative kind of thing. So decibel sort of takes that away of the subjectivity and actually put it into a number, so that it's standardized across all across the board, so that if we know that the road traffic noise is, say, generally if you're standing next to a roadway, you're and a steady traffic, you're probably going to be thinking hearing about 50, in a quiet suburban type environment. You'll see a couple of roads, you just hear different things every here now and then. Your general noise level will be about 50 to 60. Speaking level would be about 60, actually 56 to 60, depending on how close you are. But just the noise levels I'm explaining is about I measure at about 1 meter away from the source. So that's the standard measurement point. So that in reference, and in terms of hearing damage level. Your OHS, the health and safety level is about 85 dBA exposure. Now they said exposure meaning it's over a period of time. So if you 85 dB is over 8 hours, but typically, generally you don't want to be exposing yourself in that range at all. Like I would probably cap to preserve your hearing, because you may, if you work in a high noise environment already, and then you're still catching the train, and you're still, those kind of things are also added to your noise exposure, and and as time passes, your hearing will reduce because it loses the sensitivity. The same way as if Rob was to go stand next to the speaker often, his hearing will definitely drop. Like the lower level hearing, like the quieter sound, he might not be able to hear. So that's a long term damage thing. Um, and so those are the numbers we work with.
That's twice you've accused me of doing that now, Monica.
As an example.
What are you trying to say? I resemble that. Once upon a time, I used to spend a lot of time next to speakers. Okay, so we've got I guess, what a measurement of decibels is, and I think you said in the vicinity of 50 to 60 is kind of normal speaking range. So,
yep.
But when we start to get to the point of it being, I guess, at the point of tolerance, for want of a better word, from anything that's an uplift from there is then, I guess, needing to be dealt with in some way, shape, or form. So once we get to that level of tolerance, what typically is that tolerance level where it starts to go, okay, that is no longer, I guess, something that you want to deal with all the time. Now that is actually noise. Is there a defined level for that?
Not necessarily, because if you're referring to it being noise, like I think earlier we discussed, it's a perception of what is noise and what is not. But in terms of assessment and engineering of this, or control of the actual sound, there I think I mentioned 85, but obviously 85, you don't want to be designing, hearing kind of 85 dB, which is similar to like having food blender in your kitchen the entire time, in anywhere around your house. That's just stressful, and too noisy kind of thing. So, generally, just gonna give you some numbers, but you don't need to remember any of this, obviously. So in a private open space, so if you're going to a park, you would want to be hearing about 55 to 60 dB. 60 is pretty high already, but 55 is probably where you would be able to relax and actually enjoy the space as how it's intended to be used, in a bedroom settings, in a busy road environment, like an urban area. If it's a well-designed insulated building, in a living room, you expect about 40 dB. And in your bedroom, it's about 35. So a bedroom is obviously more stringent because you get awakened from it, and that's not pleasant, and it leads to a whole bunch of health issues later on if that's a common occurrence. So those are those are some typical levels there.
Okay.
Yeah.
So once we get to those typical levels, and that's, I guess, where from there on up, it's deemed to be annoying, for want of a better word. Any uplift from there, again, still measured in dB, any uplift from there, how quickly until we start to perceive, hey, I'm sitting here pleasantly enjoying my space, and then how much does it have to lift up before I actually notice that it's lifted up?
For it to in if it's the same source, so say if a road traffic noise is steady, and there's not a lot of change, a double of traffic volume, so say if there's a 10,000 car going through this road, it needs to be about 20,000 cars for you to starting to notice, I think the traffic noise has gone up. And you only just perceive it. It's not like, oh wow, that's loud kind of thing. But for it to be that kind of reaction, you're looking at maybe 10 dB, 10 to 15 dB change in the sound, the noise level, for you to go, oh wow, that's actually, that's obvious, and that could, surprise you. Yeah.
Okay, so we've measured it, we've captured it, we understand our levels. all of that sort of stuff now. I guess subject to, I guess, the source of that data. You mentioned before a couple of things when we're beside a main road or a train line. We're no longer just submitting an application through to council, but chances are we're going to have to refer to a state government agency that actually owns that road or owns the train line in order for us to understand what they, I guess, want us to actually attenuate so that people adjacent to those things don't get impacted.
Yep, that's right.
So those
So
referral agencies, who are some of them across the state, and how do
yep.
we actually, I guess, reach out and contact them?
Yep. So for Queensland, you have to go through SARA, which is a state referral agency, and usually that you go through the council person that assess your case first, and then they will let you know who the SARA contact person is, and then the SARA person then will reach out to their respective agency, which in this case for road and rail it's TMR, and
Transport and Main Roads.
yeah, transport main roads, and they'll be able to liaise via Sarah. So Sarah would have to sit in the meeting with you, and sometimes a council person will sit in it with you as well in that meeting. Oh, sorry. When I said you, it's usually the consultant and the town planner doing that fighting for you. And for New South Wales, it's the RMS. And for Victoria, unfortunately, I can't remember the name exactly, but there'll be a similar process.
Okay, so and do you know what RMS stands for? Something.
Roads and Maritime Services.
Oh, because we're gonna have boats going past us too, right? Maritime. No, I'm kidding on that one.
Yeah,
So
so I think sorry, I just realized that the change in New South Wales, I think they're all transport for New South Wales now.
okay, so but either way, whenever we're doing an application, we're no longer dealing with just our local government, local council, but we're now dealing with state government as well. And because it's a referral agency, that's going to add time to your projects, folks. And
Definitely.
that's the key point that I want to make. So if you have one of these issues or challenges and you're adjacent to, I guess, a state government noise
Assets.
asset, add a little bit of fudge factor to your holding costs and your feasibilities, because that's actually going to cost plus obviously the cost of the consultant. Good value spent on the consultant, but it's the holding cost that I'm really trying to make.
Yep.
So okay, at this point we've identified the problem, we've measured it, we can see we've actually got a problem now, and now we've got to try and control the noise. So what are the three different ways that we can actually control the level of noise?
Yep. So in general sense, in terms of engineering principle, you go back to the can you control the source? You control the path, and then you control the receiver. So first, it goes in this order as well. So you have to look at it first. This particular source, can I make it quieter? And then number two, path. Can I put something in front of it? Can I block it? Can I shift it away? Can I expand that distance between me and the source itself? And if none of those works, or combination of those, and the last one is the receiver itself. So how can I protect myself? Usually if the last resort of everything is basically PPE. Similar, you do understand that if you're in any of the industry that requires you to wear PPE, that's the last resort of protection. So in terms of development, it's actual building itself that we're trying to and protect the occupants in there. So the architectural design of that building is your last resort
So
of
let's look at
protection.
them.
Yep.
Let's look at them in that order. So from a
Yep.
source perspective,
Yep.
what are the chances that we can control the source of a main road or a train line?
Very little, if any. Unlikely you can do any of those. Having said that, if you are living in the area where roads noise are annoying you, you have the ability to actually write them a letter and said, "Hey, the noise level to my property is excessive. and I want you to come out and assess the noise level in my property. So they may have missed it in their design or whatnot. So you do have the opportunity to actually reach out and get them to assess you. Obviously, if it's you are the only one that's impacted, they might not change anything, but at least it has a record that people around this area could potentially be impacted in the future, and they might change. But that's a state government or the local council timeline. That's not in your control.
Yeah, but if it's
Yep.
another source, so like a
Such as,
pub or a
yeah,
club or something
that's
like that,
definitely. Yep.
then the control there might be, well, they might restrict the opening hours, or they might
Correct.
say that they've got to close their windows, I guess, after a certain period of time. Or so there's opportunities in some instances, depending upon what the source of that, I guess, noise
Definitely.
is. Yeah.
Definitely.
But predominantly, we're going to have a limited amount of control in being able to change the source if we kind of rule of thumb. So
Yep.
we really then got to look at the two next factors, which is an intermediate. So can we put something between the source and us?
Yep.
And then what can we do from a receiver perspective? What can we do once the noise has actually landed on us? So let's look at the intermediary side of things. What can we put in between the noise and our site in order to, I guess, diffuse the sound or dissipate the sound in some way?
Yep. So there's a couple of ways you can do this. So if you think about a noise source and a receiver, and then whatever in between is where the area where you could control it. So can you contain this? Put a barrier around the source so that you generate a barrier, a block between the source and yourself. So this is the building or a person standing, say, for example, and you've got a noise source here. So you put a barrier in front of it, or you create some sort of an obstruction to basically break that path between the noise source and you. So that could be a barrier, a fence, or the distinction between barrier and fence is quite gray, I think. But the barrier is a great big barrier that those you see it on the highway. Fences are generally residential fences. It's like 2 meters and made out of timber kind of thing. And or you can use an earth bun, which is basically you create a little hill in front of your land, if the topography allows it. Obviously that takes bigger footprints than all the barriers or the fences, so there's application for that, but not everything. You can't use it for everything.
No, but it's a little bit more aesthetically pleasing if you can do that.
That's right. So
I guess
it's more
a
clean.
giant acoustic fence sometimes is not the most attractive thing out there.
Yeah, that's right.
So, and then the last one is, I think you mentioned distance. Can we get
Oh
ourselves
yes.
further away from the
Yep.
source?
So that's part of the initial planning, the concept of so all of this design aspect comes in at the beginning, so that you set the land out right, and you're looking at it and say, okay, I know that this source is really difficult to control. I don't want to put this great big wall in front of my development. Can I put an earth band on it? If I can't, can I set back the building a little bit, so that I create a distance and therefore it reduces it? So it might be also sitting in a better topography, so that shields the road or the source noise to you. So there's several ways of doing it, but obviously it's site specific. So you need to speak to your consultants and then the planner on that element.
Okay, let's dive deep into the most common one of those, and that's really an acoustic fence. Okay,
Yep.
so that's probably the most common one that we're going to come across. Earth bun needs a lot of space,
Yep.
and as does getting further distance from the source needs a lot of space. And so sometimes that's on our smaller projects, that's not going to be a workable solution.
Yep.
Works on a bigger project for sure, but on a smaller project where we're only doing a duplex or a 4-pack or something like that, it's the acoustic fence that's probably going to be our saving grace in many instances. So,
That's right.
what are the kinds of things that we need to consider with regards to an acoustic fence, with regards to how is it actually stopping the sound?
Yeah, so acoustic fence needs to have a certain mass um, to it, and a certain density of the material that you're using to consider it as an acoustic barrier. So if it's number one of it is that it cannot have any holes. So if you've got those those typical picket fence with plenty of holes in it, that will not do anything. Similarly, if you putting hedges in or trees, that will also won't stop the sound. It will reduce, I guess, diffuse the sound, so it will deflect the sound out and make it feel like it's less harsh, or slightly quieter, but it's not going to stop it basically because there's holes everywhere. So material is important, and then there's height of the barrier and the length of it, so the coverage of the barrier, how much you're protected from the source.
And then, so from a density perspective, I've
Yep.
seen lots of different materials that acoustic fences are made of. So I've seen them made of marine ply, where it's quite dense packed, so it can be quite thin. But whilst it's physically thin, as you said, the I guess the electrons between those are actually very, very dense, and so that's
Yeah.
quite thick in it. Sorry, it's a quite thin material. But I've also seen acoustic fences made of polystyrene, and so I guess physically a lot fatter, but lighter in weight and a little bit cheaper to actually construct and that sort of thing. So,
Mm.
what are the I guess you said mass of the wall? Is it really how long does it actually take for that sound to slow down as it passes through those particles? Is that the key of it?
Yeah, basically. So just it comes down to the wave physics of it. If there is air in your material in any way, shape, or form, the sound will get through. So the denser it is, meaning the least amount of air that is compacted inside your material, the least amount of sound will travel through. So there is a minimum requirements of the wall, the surface density of the material that you can be considered as a uh, uh, acoustic fence, and that's between sometimes I think right now is 12. The standard one is that we acceptable everywhere is about 12 kilograms per square meter. Yep,
Of mass,
of surface mass.
of surface mass. So irrespective
Mm.
of the material it's actually made of. Yeah.
Yep.
Yeah. Okay. Yeah. So then, so you mentioned height and you also mentioned width when you were actually talking
Yep.
to that. So from a height perspective, I guess, is it as obvious as it sounds? The higher you go, the more sound it's going to stop.
Yeah, there is at a finite point where it doesn't serve any benefit anymore. So there depending on where your receiver location is. If you've got a high rise, say for example, barrier obviously would only you can't build the same barrier height as your building because that would be ridiculous. But if you only got one or two stories, you could potentially move that height, play with that height a little bit to optimize it to the point where um, uh, that it provides the maximum shielding for your site. So that answers actually comes out from noise modeling, an element of your consulting, your consultant on the job. So your once you engage your acoustic engineer, this will be part of their scope generally to work out what height of the wall needs to be, and what kind of shape it needs to be on like a conceptual basis. Obviously, the constructability will need to be responsible of the structural and the civil engineer.
Yep, and also the width of that wall, I guess, is it's got to be wide enough to actually make sure because sound could actually potentially go around our wall.
Yep.
It's got to be wide enough to actually cover that. Which, depending upon the rear of our site
Yep.
or wherever we're actually putting the acoustic fence, depending upon the source,
Yep.
um, it might not be enough just to put the barrier on one side. We may have to put it on multiple sides to stop the sound going around us.
That's right. So, if you think about sound, it actually propagates in a spherical. In if it's suspended in the air, it actually would propagate sound in a spherical shape. But if it sits on the ground, then it's hemispherical. And if it's actually a long long sound source, then it propagates all around that source. So similarly, if you got a string of road or a string of traffic railway, you're not going to be able to just put a barrier in front of your house and expect, the side of the railway to not make noise into your house. So because it will still come around to the side. So your barrier generally would be at the front, and then for the direct sound and anything else that comes on the side, then you have to have a wraparound of your barrier.
Yeah, yeah. And then there's, and we mentioned before, I guess, if we've got referral agencies like the main roads departments and that sort of thing of the different states, they may actually have some standards that they want their walls to actually be built to, for a whole variety of reasons. So, what are some of the considerations if you're beside a main road or if you're beside a train line? What are some of the considerations you might need to think about with regards to the standard of the wall itself?
So the wall itself, several standards would say different things. Majority of them would include the anti-graffiti type of material that you use, and some of them needs to withstand some impact, level of impact, so that in case the car does come crashing through, it doesn't just fall down, kind of thing. So so these guidelines are pretty big, and so you'll need to consult your structural engineer to confirm what exactly kind of materials you can build your walls out of.
Yeah. So when we say anti-graffiti, there's clearly people doing paint. So how easily can we clean that up? But there's also,
Yep.
I guess, people just going past and hitting the walls, and can it actually take an impact of somebody throwing stuff at it, and it doesn't want to be dented and things like that. So there's quite a bit that actually goes into it.
Yep.
Yeah. So okay. So in this instance, we can put an intermediary fence in between, but what we don't want is the Great Wall of China surrounding our property. So we
Yep.
want to put that at I guess, a reasonable standard, so it's going to attenuate some of our noise, but it's still got to be aesthetically pleasing and commercially viable, that the saleable product, because we don't want gun turrets and razor wire on the top of this fence, right? So so then there's some residual noise that might be left over on the receiver site, right?
Yep.
So what can we do at the receiver level? What are some of the things that we can consider with regards to things like our house design and house location on the block and things like that?
Yep. So there's a couple of things you could do, and it can be the layout of the building. So can you shift the building away rather than to expose it directly onto the road? If you shift it in an angle, then you reduce the angle of view to the road, and so the noise level impacted onto your that particular facade is reduced. Another thing you could do is to put a reflector on the building. So on the actual element that is weak, like say for example glass or your windows and things. So you can have a reflector there to reflect the noise out, but you can still have your windows there, but you don't have a direct view onto the road. And you see this on some of the high rises. Uh, and another thing you could do is to arrange the layout inside of your building to use the less sensitive space, such as living room, or space that you don't sleep in, basically, at the facade where it's most exposed. So, and then you put the more sensitive space, such as bedroom, in the back or far away, with a distance from the exposed sources. And another main obvious one is the actual construction itself, so the glass and the facade element. So it can be, I think, a lot of uh, cheaper construction might be you doing lightweight constructions, but those are obviously comes with a cost in terms of attenuation, the ability for it to attenuate noise coming into your space. Typically, masonry constructions are generally acceptable, and there'll be guidelines that you could reference to base your build costs from. So step back to where we were talking about the overlays and things. There's different level of categories of exposure. You could use that together with this guideline, the standard guideline that is available for public to access, not just us. You can have a look and see, oh, there are these different type of constructions that I'm going to need, and this type of glass I'm going to need. You can then gauge of how much cost you might need to use as a worst case on that side. So typically those overlays are conservative, and so your site, the survey that the consultants do during the initial part of the project would show that the noise level would be less, or if it's more than that, it's very unlikely that it is more, but it typically is less or at the same level that they predicted. You can that way. That is pretty much the worst case. You can use that as a gauge. So
Yeah. So if I was to summarize all of that up, I guess there's the orientation of the house on the site itself.
Yep.
There's the facade that would be facing the noise. So
Yep.
that facade could be a more solid structure, so brick walls, that sort of thing.
Yep.
There could be what's behind that wall. So is that going to be a less sensitive area, like a living room and that sort of thing?
Yep. So the layout.
Yep, and the layout. And then there's the penetration through that wall, which would be if we're going to put some glazing or windows and that sort of thing, there'd be the size of the glazing. Is it double glazed? A couple of elements like that to say, how do we actually minimize all of that? And then lastly, is there any insulation we could put inside the wall that could also, I guess, allow some attenuation? So all of those, I guess, are design considerations. So
Definitely. So
your architect is going to have a huge impact on that in consultation with the acoustic engineer to understand the implications of that. And I guess there's also some design guidelines with that. I know that each of the different relevant state governments provide with regards to the kinds of attenuation that you get from the kinds of material. So there's, I guess, the design guidelines for both fence materials and also the design guidelines from a house perspective. So in Queensland, I think it's the Queensland Development Code that does that. So particular section in there, yes?
yep. So yeah, at the back they basically tells you if you fall into this category of the noise overlay, this is an acceptable construction, similar to BCA. So if you use that construction, your BA certifier will sign it off pretty easily. But so you could use that as a basis. Yeah.
Yeah, so the QDC section 4.4 from memory, so Queensland Development Code. And then in New South Wales, there's also another design document there. What's the name of that document?
Yep, it's called the Development Near Busy Road and Near Railway and Busy Road. So it's by the Department of so DOP, Department of Planning, and at the back of the book it has all the different construction for different categories, so you can have a look at and gauge the construction type that you might need.
Or could, and no doubt there's other design documents from each of the other state governments, but off the top of my head, I don't know what they are, but I don't know if you know them off the top of your head.
No, unfortunately, yeah, I think these two are pretty common, and other states sometimes refer to these as well. Yep.
Okay.
And they lack off. Yep.
Yep, very good. So that's kind of dealt with it from start to finish. Now there's urban myths with regards to what people think is going to actually fix their problem. So let's kind of deal with some urban myths on this. So I guess the location or size of the fence just being on literally just on one boundary. So what's the likelihood that that's going to solve our problem in most instances?
If you're in a townhouse, maybe. However, your single townhouse, you're one of maybe, say, your end townhouses might not be protected by this. Like I think I explained a little bit earlier before about how the propagation of noise works. So if the noise does wrap around, so basically it propagate in a spherical manner. So that's the way it would go if it doesn't have any obstruction in front. So if you have a building that you put a barrier in front, the noise exposure would go over and go to the side. So obviously you have to have the right height for it to at the right height for that particular source, and then the side is also, it needs to be long enough for it to cover the exposure coming in from another angle that's not just direct.
So you might have to have some fence that wraps around your property, basically, is what you're trying to say in lay speak. Yep.
That's right.
Okay. Next urban myth. Sound only travels in a straight line.
Yes and no. there's elements of that. So not just only. So I guess that would be a no in that sense, because like I said, it actually travels in all direction all at once. So there may be one direction that is more dominant than the other if it's sort of if the source is directional. Say if you got a speaker that is a directional speaker, you point it at you, the noise source on the sound on the side might be less than the one actual in front of you, like if you're standing in front of it. So if you step around the speaker, you'll notice the difference in terms of volume.
Yep.
So no, that answer is no.
What about when you put an object in front of that? Does the sound then bend around the object?
Yes, it does. So that one is called refraction. So if you go back to the science day back in school, you're doing droplets of water with a with an obstruction in front of it. What does it do? It actually comes around to the other side in a different shape. So it's been diffused and it comes back out. There's still sound on the other side. There's still waves coming through. So it doesn't stop. Yep.
Very good. And lucky last one. Will vegetation and/or trees stop the noise?
This is a fun one. So, if you want, it does not stop the noise. As I said before, it's still porous. The material that you're putting in front of the noise, if it's porous, the sound will come through. Having said that, I think we touched on it earlier on. There's perception of sound. So if you can't see it, and the level is slightly reduced, potentially it could drop by 2 dB, or between 1 and 2 dB sometimes if the vegetation is dense enough. But having said it doesn't actually stop it completely. So you can notice the change that you don't actually see the road, and you feel that the sound is slightly less, and so you feel like yes, it's protecting, but it's actually haven't stopped it.
Very good. Monica, it's been very, very informative. So thank you very much. Monica is going to come and present a little bit more detail on some of this at one of our upcoming events in the not too distant future. Folks, we run those events all the way around the country. So we run them in Brisbane, Sydney, Melbourne, and Adelaide. You can turn up to those physically, or you can also live stream them depending upon where you're located. So Monica, thank you very much for your time
Thank
today.
you.
And looking forward to hearing, I guess, the in-depth details with some pictures and a whole bunch more at one of our upcoming meetups.
Definitely looking forward to
Okay.
it.
Until then, folks, I'm going to say bye for now.
See you guys.